Greetings, Saints, and we're live for lesson 2.3 for postulates and diagrams. And some of the things that we had discussed in this chapter is the notion of what a postulate is. In Euclid's Elements, he discusses definitions and he starts by crafting all these various definitions and as he's building this universe of geometry. And then when he extends it a little bit further, he actually starts to utilize these with some self-evident truths that are these things that we call postulates. Now, as you guys have seen in the course so far, we've been very particular about how we define things. If we give a definition for a word, making sure that that we're truly and purely pursuing that idea and not being flimsy about it. Something that can happen within this is that if we have any counterexamples, right, like when we reason inductively, it will punch a hole in our reasoning and actually kind of collapses it. So, I have said in so far in the course that a postulate is something that has a self-evident truth. Um, what your textbook just defines it as is it's a postulate is a rule that's accepted without proof. Now, this is a really difficult thing. Euclid gets five postulates in, and that's where we get the Euclid parallel postulate. It's where we get to an entire branch of geometry splinters off because of that. This is not necessarily a true statement because we start to get to what's called non-Euclidean geometry, but is spherical geometry or elliptical geometry. It's the notion then all of a sudden where we have lines that are not necessarily straight. We have obtuse angles that are or right angles, right, that are less than 90 degrees. It's really kind of an interesting set of mathematics. So yeah, it's tricky. But in strictly speaking, from Euclid's Elements, we have, exactly from one line to another line, there'll be exactly a line that is parallel to it. All right. So again, self-evident truth. Something we're not going to have to provide any more proof to. So here's one that we're going to discuss right away. It was a two-point postulate, which is through any 2 points, there is exactly one line. And then it's the line point postulate, which is a line contains at least 2 points. So I don't really beat you guys up too much if you start to confuse these two or interchangeably use these two. The same thing is effectively accomplished in both. Or so if you use one of these instead of the other, I'm somewhat forgiving. But we do need to know we're going to accept this just to be true without further proof. Next, we have the line intersection postulate. So we're gonna work through this chapter. Work through this chapter. Sorry, is at exactly 1 point. So line intersection postulate: if two lines intersect, then their intersection is at exactly 1 point. Third time. If when we work through this chapter, you guys are gonna see we've been building this universe of geometry. So thing by thing, idea by idea, definition by definition. And then now we've already discussed this in the first chapter, and now we actually are just going to give it its own official postulate that we can now cite as we're continuing to build in our universe. So we have two intersecting lines. Their intersection happens at a point. Okay, has to. Not going to happen at multiple points. And if it is no intersection, then it is parallel. For the 3-point postulate, which states through any three non-collinear points, there exists exactly one plane. And the plane point postulate, because this is similar like the 2-point postulate to the line point postulate. So the plane point postulate says that a plane contains at least 3 non-collinear points. So I want you guys to think about this inductively for just a moment. So all we need is a single counter example to foil our argument. For example, the sun is going to come up tomorrow. Not to get kind of dark on you guys, but no pun intended. But the sun is going to come up tomorrow. Has some faulty reasoning, even though it's fairly definite. If there is an exception um, to that truth, before we just accept it to be true, what would even if it's an infinitesimally small has an infinitesimally small possibility for it to happen. For example, a supernova suddenly tomorrow, even though it's not scheduled for billions of years, or if there was an issue with I know an asteroid were to hit the Earth, right? We could not then see the sun come up, or a number of things that could happen to this planet, or to the sun, or something within the solar system that's going to disrupt the sun coming up tomorrow. Could happen suddenly. So it's not definite, right? It's a one in a gazillion chance, but it means that it's not necessarily a true statement, right? That is not true. The sun will definitely come up tomorrow. I cannot say that definitively. Here's um an issue here is that if we have to make sure that we define things, because here's the plane point postulate, actually the 2 point postulate, the line point postulate, right? Where we have two lines or 2 points where a line goes through them, and we have to make sure that we have this very carefully defined with non-collinear, because if we don't define that and throw that in there, right, and we put a third point that's collinear, this is a counterexample to this plane, because we could do an infinite number of planes crossing through that line over and over again. So we need to make sure that we say that these guys are non-collinears, right? So we have one and two, and then a third one, for example, right over here or anywhere else. Okay, so getting back to this. Almost finished up here with the plane line postulate, which says if 2 points lie in a plane, then the line containing them lies in the plane. Okay? Should make sense, because if the 2 points lie in the plane, there's exactly one line that goes through them. If those 2 points were in the plane, then the line would also have to be in that plane, right? Because the 2 points would be on that line. And the line would be through those 2 points. Those two coplanar points. And last but not least for today, we have the plane intersection postulate. Well, we know that two lines intersect at exactly a point, and if we have two planes that intersect, how do they do so? But at exactly one line. Okay, so this is what I got for you guys for today. Lots of work to do. When we get to class, we're going to be utilizing these postulates to execute our exercises. We also are going to discuss a little bit more about explicit equations versus recursive equations. Explicit being deductive, recursive being inductive. All right. I will see you guys in class. Good luck.